This meeting is being recorded.
Yeah, you're all set. You can start with your introduction, Vishak.
Hi, so I have like 7 years experience developing. I started with the development experience first, then recently I moved into uh, generative AI and prompt engineering and basically ML ops for the since like the past 2.5 years to 3 years. The recent projects I've been working is one is building a custom copilot for my current project,
Mm-hmm.
where we are using it's an insurance-based project, and we had this issue of claim handlers working with customers directly when they have to
Mm-hmm.
reference documents, policy documents, or claim documents, medical documents. All these things take up a lot of time while they are having customers on the call. So to solve this particular problem, we introduced a custom code pilot. Basically, it's we have a LLM model which is using a RAG pipeline, and it references all the claim documents and all those things. We build a RAG basically on top of this particular document or database, and that generates whatever information the claim handlers or the customers that are looking for. All you just need to do is basically chat with it directly, and the UI we built is on React for this particular thing, since it's just a simple web chat. And
Okay.
the entire architecture is basically we had the data ingestion layer where we chunk all the
So,
databases into.
Vishak, I'm sorry to interrupt. You will go in details about it. Explain.
Okay.
Let's just start with talk about more your transition from data scientist into machine learning or AI ML or generative side. So, talk more about it.
Okay. So initially, as I said, I initially started with more like building ETL jobs, like ETL data transformation, cleaning up, and then moving to building more what do you call it? Reporting and analysis tools from data science. Like we had so many matplotlib and those kind of functions. That's what I initially started up. But as we transition into recently with building I learned with TensorFlow and the other one, like what's the one from Meta.
Mm-hmm.
So learning all these models, I felt like it was much easier for me to transition from data science into MLOps. Uh, as both have the same what do you call it? The baseline, the foundations.
Mm-hmm.
So ML is more like a more concentrated field of what you do in data analysis. So it's the same mathematical models that you build in data science and all these
Mm-hmm.
things that you are much more concentrated in machine learning. The same stochastic gradient,
Mm-hmm.
uh, the mean reasoning, the MMR, we call it, or the RY curve, the fun score, everything we use in data science is just basically applied to specific supervised or unsupervised models that we are using in machine learning. It doesn't matter if it's just an SVM or if it's an LLM. So that transition was much easier for me to do it. The only part I had to learn a little more to transition was the infrastructure side, because I
Mm-hmm.
don't think building an LLM or implementing an LLM is that hard, but you need to have the right
Approach.
infra to support it.
Correct.
Yeah,
Approach and infra to support. That's very well
yeah.
said. Vishak, can you differentiate
Mm.
what is supervised and unsupervised learning?
In case of unsupervised, you will have like more raw data, like
Mm-hmm.
it's not particularly labeled or unstructured.
Mm-hmm.
So when you're what we use for LLM in case of unsupervised learning is giving the initial context, like teaching the model how to speak, to look for context and everything. That's where we use unsupervised learning. And when we go to supervised, you have more structure, more clean, more labeled data. When we want much more domain specific knowledge to give to the LLM instead of
Got it.
just
Got it.
more
And
generic or
how would you define overlifting, overfitting? Sorry, overlifting. So again, how would you
overfitting.
define
Yeah.
overfitting? Yeah.
Overfitting is when happens when the model is too good in prediction, like it what did you say? I can give you a better example. So it basically memorizes the answer rather than actually analyzing the model.
Okay.
So if I say, for example, if we just give the reasoning as 1 plus 1 to give it answer for it, it just memorizes the answer, and rather than just calculating or using the tools to do it. And this is a very common problem where it happens like when there is the data is we are feeding the training data we are feeding is very less or little ambiguous. The system just models these vectors to directly to those data rather than analyzing or
Mm. Okay.
making
Okay.
its own inferences.
And how would you define precision recall and F1 score?
Precision comes with it's just about eliminating like the more false positives.
Mm-hmm.
It's it's more focused on giving out much more the right answer,
Mm-hmm.
and the recall would be like will be the it, it makes sure that the overfitting is much more less when you use it more. And finally, for the F1 score, it's finally the one that gives the uh, model accuracy, the LLM
Balancing,
accuracy.
basically both balancing in both.
Mm,
Okay. Yeah, yeah.
correct.
And what feature engineering techniques have you used so far?
Uh, I would say one of the most common is will be the principal component analysis. Will
PCA.
be
Yeah, yeah.
yeah PCM, yeah. So when you have like usually you're going to be involved with so many features in when
Mm.
you're giving input to, let's just say it's going to be 30 to 35 features, but the more features you add, the correlation factors and even the uh, hallucination, the way everything decreases as you add more and more features. So it's much more better to if you can bring down that to much more the ones you have much more correlated to the result. If you
Mhm.
are able to engineer it in that way, you can
Okay.
have better
Okay.
precision and
Understood.
better recall.
Uh, have you implemented any ML algorithm in any of your projects? I see your project is very long. So,
Mm,
any project, in any of your project, you must have worked with different within different projects, right? Within the same client,
correct.
different projects, correct?
Mm.
So, did you get chance to implement ML algorithm so far?
Uh, if you, I mean, you can say reinforced learning is one of the common techniques if you're asking that something like that.
Okay.
So, especially for feedback learning,
Mm-hmm.
for the same chat application that I mentioned, uh, users can always give you, like, say, for example, that LLM is giving a wrong answer and the user is not particularly uh, he doesn't want that. He's not impressed with the answer and he can just mark it as a false input. In that case, we have like a feedback loop where we give this a ranking system kind of thing that we feed back to the LLM, where it ranks the right answer so that the next time when a different user asks the same question, it knows to make sure that it gives a better answer this time rather than giving out the same
Okay.
old answer
Okay.
as a false one.
Same learned answers.
Mm,
Okay.
correct.
And how would you deploy ML models into production?
Okay, so we used like a cloud infrastructure for it.
Okay.
We have like different layers where LLMs where we hosted in a Bedrock, AWS Bedrock basically,
Mm-hmm.
and we had one orchestration layer, one data ingestion layer, and one API gateway layer, and one for the prompt generation, everything. So basically, whatever the user is giving the prompt, we restructurized everything into um, much more readable way for the LLMs to reduce the token usage and everything. And
Okay.
finally, the uh, okay, one more name. Yeah, the Landgraph stage where we maintain the state for the entire orchestration
Okay.
and the
Okay.
telemetry analysis, basically the monitoring and
Have you
telemetry.
have you built any ML pipelines?
Yes, this whole thing, like not just for this Copilot alone, we had this agentic AI as well. Like we created like automated the invoice generation and uh,
Mm.
basically it pulls the invoice data from different systems like policy system, billing system, claim center, and all these three systems. It pulls the data, and we have one agent to particularly evaluate the what do you call that, the if the data is all okay, It's it basically just the data validation part. If everything is cleaned, everything, there's no missing data values. If
Okay.
all the rating policies is exactly the right what you're looking for, and
Okay.
those kind of pipelines, it goes through different systems, right? So we had to use like something like an MCP to pull the tools from different systems, and skill set, like different skill set that we already built in, like to teach these agents on how to build this invoice and everything, rather than generating a new code every time to deal with different scenarios.
Okay. 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 Awesome. And can you walk me through your LLM projects where you have worked in your recent project? What kind of work you have done related to LLM projects?
Yes, I worked on the fine tuning part and as well as
Wow.
the orchestration part, where we set up the land graph for all the the orchestration of different, basically the different chunking, embedding, vector databases, and all these things that happens through land graph basically. And that particular part, and even the rack system that we built, we had to like do all these validations, coming up with all the recall scores, the KV caching, all these things. We had to make sure the key value is reused exactly as it's supposed to be, rather than just hallucinating on old results. And it makes sure that the feedback loop is also um, executing as expected, like making sure that the model is not stuck in its own old process, in its old state basically.
Got it. And what is RAG? When did you
RAG
use
is
RAG and
the
what is RAG?
Yeah, it's a retrieval augmented system. So it's
Mhm.
basically just helps. It's a database system that allows, particularly, like say for example, it's if you're having a few specific documents or knowledge base that you just have to reference it. The LLM, it uses its own context that is built on to bring the information to you, but RAG will help you give much more nuanced into it. Instead of saying like referencing something like it had learned, it will look in the documents that we are providing it into it.
Okay.
uh, it doesn't matter, it's all basically just a much more concise vector embeds that helps the LLM.
Okay.
You
Very
can consider
nice.
it more like an open
You
book
were
exam.
talking about fine tuning, right? So have you done
Mhm.
fine tuning in RAG, or just walk me through the fine tuning process in RAG?
No, fine tuning is, if I'm saying like on the model itself. So a RAG is completely different from fine tuning, right? So basically, if when you're using RAG, it
See,
means
okay,
like
let me rephrase my question. Instead of RAG, instead of fine tuning, what is the advantage of using RAG? Make sense now?
Sure. Yeah, that makes sense. Okay, you have to go for RAG when the documents are much more frequently changing. If the
Mm-hmm.
knowledge base gets updated much more, uh, you can say like the knowledge base is one of the thing example I can say, because you will always be updating the documents. The claim documents will be always be updating it per every term. When there is the data involved is much more volatile, RAG performs much more better, as the LLM doesn't have to be learning all these new documents. They just have to reference the static documents that you're providing it. So it just references this RAG pipeline and just gives you the better answer. But when you change the core domain knowledge itself, in that case, fine tuning works better, because we change the fundamental knowledge base of the entire model itself. So in that case, fine tuning is better.
Okay, and how would you reduce hallucination?
Yeah, there are so many techniques. One of the common thing I said is user review and feedback learning through reinforced learning. So this will give the model, and also very simpler thing I would say is start with much more healthy metadata, because if you have loose and very ambiguous data that is feeding to the model, uh, your embeddings and vector database that you're generating won't be that strong, and that
Mm-hmm.
LLM model will create some weak links that don't even exist. But because LLMs are just basically a probability model, they don't really analyze the data we are providing. They just create links, or it's just a mathematical model that generates the most probable next word. So when you are not giving it much more rigid structure like a reinforced learning to tell that it is making the wrong inference, it's just going to keep making that uh, wrong inference and going to give you the wrong answers and giving you hallucinations.
Okay. I think we are good, Vishak, and I hope you are
Okay.
aware that this manager will do just one round and done. So you are available for in-person interview in Charlotte office, right?
Yeah, I am.
Any specific time? Maybe if we set up, what is date
Uh,
today? This week,
okay.
20, not today, not tomorrow, Thursday, Friday, anytime you are available, or I can directly set up on 25th.
Uh, 25th. Okay, 25th are a holiday for a bank or something, or offices.
Sorry?
If 29th is not, I thought it's a holiday this weekend like this. Let me just check.
Oh, yeah, 25th is holiday, Memorial Day, and
Yeah.
26th. Yeah,
Yeah, I don't
I
mind.
can
Like,
schedule. Yeah, I can schedule on 26th. I actually I also missed from
okay.
my end. So Thursday, Friday, or Tuesday, I will put. I will let
Yes.
manager know. Yeah,
I would just prefer the timing in advance alone. Like, since I have to, I'm in
in
Raleigh
afternoon.
actually. I have to make the travel.
Travel. Okay, I will give you at least 48 hours of a notice since you will be traveling from
Okay.
Raleigh, right? Raleigh or Cary?
Correct. Correct. Yeah,
Raleigh.
Raleigh.
Yeah. So yeah, I think nice talking to you, Vishak. Once again, thank you so much for joining
Yeah,
in,
yeah, yeah.
and I will try to set up
Definitely.
as
Yeah.
quickly as possible. Thank you.
Yeah. Thank you so much.